Okay, guys, so now we're going to start to talk about transformations of random variables. Now that we have a better understanding of random variables from the preview and then our class today or yesterday, depending on when we're watching it, now we have to understand what happens when we do things to our random variables, like add, subtract, multiply, divide, and then eventually we're going to be combining them, okay? So it's really important to realize that we have done this before. It's an important idea because it's pretty much the same as what we've done before, okay? So we did study the effects of linear transformations on the shape, the center, and spread of a distribution of quantitative data way back in Unit 1, okay? So we did see that when we added or subtracted a constant to A for each observation, that you add A to measures of center and location, it does not change the shape or the measures of spread. But when you multiply or divide each observation by a constant, you multiply measures of center and location, and you multiply measures of spread. It also, though, does not change the shape of the distribution. So we're just going to be going through kind of the same example, but we're going to be changing and doing different things to the same example as we go, so we could kind of get an idea of how to do it, okay? Okay, so I'm going to constantly be referring to this example. So it's just a very simple example to start with, and then we're going to kind of keep building on it, looking at adding and subtracting, multiplying, and dividing, and then we're going to start to combine random variables, okay? So we'll start very simple, okay? So Pete's Jeep Tours, okay? They offer a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers, okay? So we definitely have a random variable here. So X is going to be the number of passengers. So it's a random variable because it's a numerical value from some chance process. So probably over a series of maybe a tourist season, they calculated how many times you had 2 passengers out of the total and 3 passengers and so on, okay? So these probabilities are coming from probably some historical records of Pete's Jeep Tours business, okay? So now we know how to find our mean and our standard deviation of this, right? So the mean is going to be found here by taking that's your expected value, right? Taking your number of passengers, multiplying it by your probability, and then adding all of them, right? So 3 times 0.25 plus 4 times 0.35, and getting the sum of all of them, okay? So that's going to be 3.75, okay? Your standard deviation comes from the squaring your variance. So first your variance is going to come from taking each value, subtracting the expected value, or your mean, squaring it, and then multiplying that by the probability of that value, okay? And you're going to do that for each one of your values. And you will end up with 1.1875, okay? Your variance is 1.1875. Your square root of that would be your standard deviation. Okay, so our standard deviation here is going to be 1.0897 for Pete's Jeep Tours. So our expected value, or the average value, or the average amount of passengers would be 3.75, where your typical, on a typical day would vary by about 1.0897 from the mean. Okay. So now let's take a look at what happens if I twist it a little bit, okay? So now let's say instead of referring to the number of passengers, let's talk about how much money Pete is collecting on on a randomly selected day. So in order to know this, I have to know how much money he's charging. So let's suppose he charges $150 per passenger, okay? So the total money collected, let's say let C equal, I guess, amount of money collected on a randomly selected day. Okay, so I have the total collected money, right, the value of C, right? So if he has 2 passengers, he could possibly collect 300, right? 450, 600, and so on, okay? And the probability is not going to change. Okay. How much they're paying is not going to change the probabilities here, okay? So when you go ahead and try to go through your mean all over again, it ends up being the same thing, okay? You're going to take your value, your collected money, multiply it by the probability, add it to each one of them, okay? So you're going to end up with a mean of $562.50. So the average amount collected, $562.50. Okay. Your standard deviation is going to be found from taking the money collected, subtracting it from your $562.50, your expected value, squaring that, and then multiplying it by your probability, adding that to your all of your possible outcomes, your 2, your 3, your 4, your 5, and your 6, because they hold up to 6 passengers, okay? You end up with a variance of 163.46, okay? So then your square root of that would be your standard deviation, which here is going to be, oh, wait, no, I jumped the gun here. Well, okay, well, doing all that and squaring it is going to end up with being 163.46, so $163.46. Okay, but going through all of this is very much unnecessary because we know now it's like our linear transformations that all you have to do is just simply multiply, okay? So you're going to take your mean of 3.75 and multiply it by 150 to get your new mean for your collected money, 562.50. Same with the standard deviation. The standard deviation also gets multiplied by an absolute value. So your 1.0897 gets multiplied by the 150 per passenger to give you $163.46 for your standard deviation. Okay. Your shape, however, would not change. And let's end that one here.